here we're going to look at systems with infinitely many solutions or no solution. The concept in the start of this is the same, where we're using the substitution method and taking our y equals 3x plus 1 and replacing the y value with 3x plus 1. Sorry about that. So we have 6x minus 2 times the quantity 3x plus 1, and all of that is going to be equal to negative 2. So again, we're taking our y value and just substituting. So we would distribute of 6x, and that negative 2 will get distributed in. The screen is not cooperating with me today. So that negative 2 will get distributed in, and we're left with negative 6 and negative 2, and that will be equal to negative 2. Now notice that we have 6x minus 6x. So those would cancel out, and we would be left with negative 2. Negative 2 is equal to negative 2. Well, that's a true statement, right? Everyone would agree that negative 2 is equal to negative 2. And no matter what, that is always going to be true. What this means is that effectively these are the same line. If you were to plot these, they would overlap. But since this is a true statement, negative 2 does equal negative 2, then we're going to state that there are infinitely many solutions. And we can stop there. That's all we need to state for this specific problem. But anytime you get a true statement, something like 5 equals 5, or 100 equals 100, or negative 1/2 equals negative 1/2, if it's a true statement, it winds up being infinitely many solutions. No matter what happens, those two statements will be equal to one another. Now let's take a look at part B. And again, if you kind of have any idea of what might happen, is it's probably going to be a no solution problem. So we have y is equal to 5x minus 4, and I'm going to replace my y value with 5x minus 4. Now we do want to be careful here. You have 5x minus, and then that y value is going to be replaced with 5x minus 4, and that will be negative 4. Make sure you put that expression in parentheses, because this subtraction sign right here applies to the entire term. Okay, so again, be very careful with that. So we're going to take that negative, treat it like a negative 1, and distribute it in. So we have 5x minus 5x plus 4 equals negative 4. Now again, like in part A where the 6x minus 6x canceled out, the 5x minus 5 drops out, cancels out, and we're left with 4. There's only a minute left in this video, so hopefully this sticks with me. We have 4 is equal to negative 4, and clearly that is a false statement. 4 does not equal negative 4. So if they are non-equal, we're going to state that there is no solution. Right, so what will happen is these will never work out. No matter what values we plug in, they'll never be equal to one another. If you were to look at these on a graph, you would see that they are parallel lines. So the concept of infinitely many solutions and no solutions is pretty straightforward. If you have a true statement, that's infinite solutions. If you have a false statement, that's going to be no solution. So we'll say infinite solutions and no solutions. So keep that in mind when you're solving these. Be careful with your signs as always, and you shouldn't have too much trouble with this concept.